line spectrum of hydrogen which consists of 5 main series, and it is named as Lyman Series, Balmer Series, Parchment Series, Bracket Series and Fund Series. What is the discontinuous emission spectrum? It is also known as line spectrum or the atomic spectra. Redbug equation that we use to calculate the types of radiation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called structure of atom. Under that, we also discussed about the Planck's constant and the photoelectric effect or the photoelectrical current. So, these two concepts were studied by the two different scientists, that is the Planck's as well as with the Einstein. Today, let us move on to the next topic of this unit about the dual behavior of electromagnetic spectrum, and we are also going to discuss with the atomic spectrum. So first we will understand what is the dual behavior of electromagnetic spectrum. So from the studies of behavior of the light, so there are so many scientists group, they have studied only the behavior of the light and they have come to the conclusion that all light or all electromagnetic radiation, they have a dual behavior. What is the dual behavior? So they behave like a both wave as well as the particle. So all the scientist group, they have studied about the behavior of the light and they come to the conclusion that the light will behave like a particle as well as the wave nature. So this was a study was brought about by the groups of scientists. So whenever the radiations, when it is interacts with the matter, it displayed the particles property and contrast with the wave-like property which exhibits when it is propagate. Here you can see that when a light, when it touches to the particular matter, it behaves like a particle. The same light, when it is touches to the particle, it behaves like a wave. So here they have understood that our all lights, they shows a particle as well as the wave nature. Hence it is known as a dual nature of the light or the dual nature of electromagnetic radiation, and it was studied by the group of scientists. Let us see now what is a spectrum. Spectrum is a group of band of wavelength or a colors. It is known as spectrum. It is a group of band of wavelength. How do we get this wavelength? When a white light is passed through the prism, it will be split and give rise to the band of 7 color. Here you are passing the white light to the prism and this light will be split and produces a band. So that consists of 7 different colors. That is known as spectrum. So how do we obtain the spectrum or how do we obtain the band? So the band will be produced by passing the white light to the prism. So it will split and produces the band and it consists of 7 different colors. And the study of emission or the absorption spectra, it is known as spectroscopy. The study of this emission and absorption spectra, which is generally known as spectroscopy, and there are 2 types of spectrum will be there, that is the emission spectrum and the absorption spectrum. Now let us understand what is the emission spectrum. Just now we have understood that what is the spectrum. Spectrum means it is nothing but a number of bands which is produced. How do we obtain the number of bands? Simply by passing a white light to the prism, so it will split and produces a band. Okay, and there are 2 types of the spectrums will be there: emission spectrum and absorption spectrum. Now let us see what is the emission spectrum. When the radiation which is emitted from the source are incident on the prism or separated into different wavelength and obtained by photographic plate. Here you can see that how the wavelength will be get separated into the different bands and it will be collected on the photographic plate, and this is the emission spectrum of the iron. So this shows that this is an emission spectrum. What is the emission spectrum means? It is the radiations which is emitted from the source. When the radiations are emitted from the source, you know, it will be get separated into wavelength. So it will be get separated into wavelength and it can be absorbed or it can be collected by using photographic plate. And again, this emission spectrums are of two types. They are continuous spectrum and discontinuous emission spectrum. Now let us understand what is an emission spectrum. Continuous emission spectrum. Continuous emission spectrum means there is no gap between the various wavelengths and one wavelength can be merged with the another one. Here we have understood that emission spectrum means it is a emission of radiation from the particular sources where the wavelength will be get separated. When I say it is a continuous emission spectrum, there is no gap in the wavelength and one wavelength which is merges with one another. For example, in the Vidhyaashram, you know, you can see that all the violet, blue and green, yellow, orange and red, all these colors, you know, they merges with one another. There is no separations of all this color with the wavelength. Hence it is known as continuous emission spectrum where the white light is passed through the prism and it will be split into the different colors and all these colors, you know, they merge with one another with a different wavelength. Hence it is known as continuous emission spectrum. Now let us see what is the discontinuous emission spectrum. It is also known as line spectrum or the atomic spectra. In this, certain wavelength will be goes missing from a group or leaves a dark space in between and giving a discontinuous spectrum. Hence it is known as discontinuous emission spectrum. The name itself shows that it is a discontinuous. After when you pass the white light to the prism, you know, it will be get separated into different wavelengths. Some of the spectrum which is also get missed. Here you can see that here we got the two yellow lines which is get separated with the two different wavelengths, and some of the wavelength also they get missed in the particular group. Hence it is known as discontinuous emission spectrum. Now let us see what is an absorption spectrum. When a light from the particular source or from the any sources is first passed through the solution of chemical substances and then it is analyzed, it is observed that there is some dark lines in the absorption spectrum. So how do we obtain the absorption spectra? Here we are passing the light from the any sources, we are passing the light to the chemical substances which is taken in the container. So what do we observe here? Here the lines or the spectrum will be obtained in the form of dark lines. Here you can see that the dark lines which has been produced. So since these dark lines which indicates that some of the spectrum which is observed, it is observed, hence it is known as absorption spectrum. Why does it get absorbed? Because you are passing the light to the solution or to the chemical substances so that it will be get absorbed and it will be produced as a dark line. Next, we'll see with the line spectrum of hydrogen. So what is the line spectrum of hydrogen? Let us understand. When an electrical discharge is passed through the gases of hydrogen, the H2 molecules will be dissociated and energetically excited, and a hydrogen atom will be produced as the emitted electromagnetic radiation of discrete frequency. Suppose, imagine this is an hydrogen atom which consists of only one electrons in the K shell, as we know that. Similarly, if you take the number of hydrogen atoms, you know, it will become a hydrogen molecule. Is it right? Hydrogen molecule. when you apply the electrical field to this hydrogen molecule, what will happen? This hydrogen atom will get energy and get excited. When they get excited, it will be get shifted to the higher energy level. It will be goes to the next higher energy level. When they get excited, they produces the electromagnetic radiation. So the hydrogen spectra, which consists of several lines, and it is named one after the discovery. Here, line spectrum of hydrogen, which consists of 5 main series, and it is named as Lyman Series, Balmer Series, Parchment Series, Bracket Series, and Fund Series. Here P is silent. So how many series are there? There are 5 series will be there. That is a first one known as Lyman Series, Balmer Series, Parchment Series, Bracket Series, and the Fund Series. How do we obtain all this series? Only when you apply the electrical current to the hydrogen molecule. When the hydrogen molecule receives the electrical current, it gains the energy and get excited. When they get excited, it will be goes to the next higher level. During this process, it produces a electromagnetic radiation, or the energy will be produced. That is why the energy levels of this hydrogens, which is classified into Lyman, Balmer, Parchment, and a bracket as well as a Fund series. Now let us see what is this Lyman series first. Okay, Lyman series means when the electrons are jumped from any higher state to the ground state or from the first state. The series of the spectral lines are emitted lies in the ultraviolet regions, hence it is known as Lyman series. When the electrons are get excited from the ground state to the next higher states, it produces it emits the electromagnetic radiation, and this comes under the ultraviolet region, hence it is named as a Lyman series. It was discovered by the Lyman, hence it is known as a Lyman series, where the electron from the ground state, it will be get excited to the any other state, and again after losing its energy, it comes back to the original state. In this, the Redbug equation of the formula can be written as where n is equal to 1 and n2 can be 2, 3, 4, 5, which means to say that when it gives the energy, hydrogen atom can be shifted to the second or to the third or to the fourth or to the fifth series. Similarly, we can define the Balmer series. What does the Balmer series says here? Here the n is equal to 2. Why it is 2? Because the electrons jumps will be starts from n is equal to 2. That is to the second series. Okay. So where n is equal to 2, from the second to the third, to the fourth, and to the fifth, and to the sixth, it will be start jumping when it receives the energy. When the electron jump from any of the higher state to the state with n is equal to 2, with the series of spectral lines will be get emitted and lies in a visible region, and it is known as Balmer series. Here you can see that this is a Balmer series where the hydrogen atom, which will be in the ground state where n is equal to 2. When n is equal to 2, when it gains the energy, it will be shifted to n is equal to 3, or it may shift it to n is equal to 4, or it may shift it to n is equal to 5, or it may shift to the n is equal to 6, or it may get excited to the n is equal to 6. And this series will be obtained in the visible region, hence it is known as a visible region, and this was discovered by the Balmer. Next, Parchment series. The same year, in the Parchment series, the hydrogen atom were in the ground state where n is equal to 3. When the hydrogen atom in the third stage, when it receives the energy, it will get excited to the fourth, to the fifth, and to the sixth. Like this, it produces the electromagnetic lines when it is get excited. How they get excited? When they receive the energy. So that Redbug equations will be become n1 is equal to 3 and n2 may be 4, 5, 6. Similarly, the bracket series also we can define it, where in the bracket series n is equal to 4. The electrons which is present in the ground state, that is on the 4th position. When they get energy, it will get shifted to the 5th and to the 6th. So that N1 is equal to 4 and N2 will be 5, 6, 7. And it produces electromagnetic lines. And hence it falls on a infrared region. You can see here the Parchment series and near the infrared and the bracket series which is far from the infrared region. It falls on the infrared region. Next we'll move on to the Fund series. Here the last where the electrons which is present n is equal to 5. When the electrons are at this ground state, when it receives the energy, directly shift to the 6th state. So that N1 is equal to 5 and N2 may be 6, 7, 8 and it is also falls on the infrared region. Hence it is known as a Fund series where P is silent. Then what is the ionization energy? The energy is required to remove an electron completely from an atom as to convert into positive ion. Suppose if you remove that electron completely from an atom, what will happen? The entire atom will be gains a positive charge. For example, in the hydrogen, we know that atomic number will be 1. Is it right? When it loses one electron, this hydrogen atom will gain the positive charge. In such cases, what will happen? N1 will be 1, whereas N2 will be infinity. So, this concept was studied after the discovery of Lyman, Balmer, Paschen, bracket and the Fund series. Hence, it is known as a line spectrum of hydrogen. Just remember, in case of the hydrogen, what they have done? They have taken the hydrogen gas and they passes the electrical current. When pass the electrical current to the hydrogen gas molecules, they get dissociated and produces the electromagnetic lines. So, this will be get absorbed by or discovered by the Lyman, Balmer, Paschen, bracket and the Fund series where the electrons in the ground state to the excited state, they get shifted. Why they get shifted from the lower energy level to the higher energy level? After gaining the energy. Hope you all understood with this concept. Let us move on to the Redbug Equation. So, it allows the calculation of wavelength of all spectral lines of the hydrogen, and this Redbug Equation that we use to calculate the types of radiation. 109677 into 1 divided by n1 square minus n2 square into per centimeter. If you put the values of the n, suppose in the Lyman series we understood that n1 is equal to 1 and n2 will be 2. So, V bar which is equal to 19677 into 1 divided by 1 square minus 1 divided by 2 square. So, if you subtract these two, you will get the answer and that shows that the types of radiations will be ultraviolet. Similarly, you can go with the Balmer and you will get a visible region, whereas in the Parchment you will get the infrared region, whereas in the bracket n is equal to 4, hence it is infrared, whereas in the Fund n is equal to 5 and n2 will be 6, 7, 8. So, you will get the infrared region and this Redbug Equation was first found out by the Balmer. Okay, and this equation we use to calculate the wavelength of the all spectral lines of the hydrogen. Hope you are understood with this concept. In the next session, we are going to understand with the Bohr theory of atomic model. And by this, I like to say that whatever we discussed in this session, it is very important for your competitive exam as well as for your board exam. Have a look on this and try to work hard, and we will meet you in the next session. Till that, take care. See you.